Hey everybody, hope you're doing well today. I thought I would take a short break between some other chores and repackage a video. I say repackaging because this is a video that was originally created in the fall of 2020 for my ergonomics class. There will be reference made to assignments and problems and so on and so forth. Just ignore those any mention of outside homework. Now, if you are an NSU student and you would like to complete the problem, complete the readings, whatever is mentioned in the video, you're more than welcome to do that. Just let me know, send me an email, and I will send you those materials. This video focuses on using the ACGIH tables that provide us with recommended lifting limits for different tasks, especially repetitive tasks like loading boxes off an assembly line 50 or 60 times or 100 times every hour. And that's where this particular table is useful. And I won't say any more about it right now because that's what the video does, but if you do have any questions, let me know, and I'll do my best to answer those questions. All right, well, let's go ahead and get started. And we're using the ACGIH TLV for lifting tasks. This is a policy that some companies may adopt as their policy when it comes to any task that requires lifting, especially repeated lifting of objects. As I've said before, there are no OSHA requirements when it comes to ergonomics. There are no lifting limits within the OSHA regulations. But we do have lifting limits coming from other agencies. And one of those agencies is the American Conference of Governmental Industrial Hygienists. That's what ACGIH stands for. And I'm sure most of you have heard this already in industrial hygiene. This probably isn't coming as a new organization for most of you. This is a recommendation. This is not a law. If companies were to follow this recommendation, they would not have very many problems with lifting related injuries. It is kind of difficult for some companies to implement though, because their recommendations are very conservative, as you'll see as we go along. The TLVs for lifting from the ACGIH are found in a table that we see here that's broken down into 3 subtables. And this is the only reference you need to use the TLVs for lifting from this organization. And it can be used to determine the maximum load weight, and it looks at 3 variables to determine what the maximum load weight will be. Lifting frequency, the vertical zone, which we'll talk about what we mean by vertical zone, and the horizontal zone. Based upon these 3 variables, there will be a recommended weight limit that we will take from one of these 3 tables. Now, this assumes that we have optimal lifting conditions. It assumes that the worker has a good grip. It also assumes that all the workers are healthy before they start the task. And it wouldn't apply to a worker that has a previous back injury or shoulder injury or epicondylitis or any other type of ergonomic injury before they start the task. Now, if there are suboptimal conditions, or if the worker has been previously injured, the limits would have to be reduced. And I would argue if the worker is still experiencing a previous injury, they've not fully recovered, they still shouldn't be performing any kind of lifting task anyway. So, moving on, let's talk more about what we mean by frequency. And frequency, the lifting frequency will determine which subtable, or we can use table 1, table 2, or table 3. Okay, there are 3 categories of frequency. Low frequency is subtable 1. That's less than 2 hours a day with no more than 60 lifts an hour. Or it could be more than 2 hours a day with 12 lifts an hour, no more than 12 lifts an hour. Either of those options would be considered low frequency, or either of those work situations would be considered low frequency. Moderate frequency, less than 2 hours, 60 to 360 lifts an hour. Or more than 2 hours with 12 to 30 lifts per hour. Then high frequency, which would be subtable 3, more than 2 hours a day with 30 to 360 lifts per hour. Okay, so this is what we mean by frequency when we're using the table. And again, we use frequency to determine which subtable we are going to use. Another variable that's used to determine the lifting limit is horizontal zone. And this is what the ACGIH means by horizontal zone. It's the distance perpendicular to the worker at the start of the lift. That's the distance out in front of you. If your arms are extended in front of you, it's that perpendicular distance to the plane of your body. This distance is measured from a midpoint that starts between your ankles. That's what this red dashed line indicates. This is the starting point for determining that horizontal distance and horizontal zone. From the midpoint between the ankles out to the center of the hands. Close would be if the load stays less than 12 inches from the body. As indicated in the chart here, this would be a close lifting task if you're able to keep whatever it is you're lifting close to the body in that range. The mid-range is 12 to 24 inches. Then the other category for the horizontal zone is over 24 inches out to 31 inches. Now this table doesn't apply if the lifting or if the horizontal zone is greater than 31 inches. The ACGIH takes the position that if the load is further than 31 inches from the body, they shouldn't be making that lift at all. There's no safe weight at that horizontal distance. As you know, from the further the load is from your body, the greater the force generated by the load, and the greater the impact on the body as that distance increases. So again, this is horizontal zone. Vertical zone has to do with the height of the load at the start of the lift. Not where it ends, but at the start of the lift. There's mid-shin to floor over here. This is the mid-shin to floor zone. Technical difficulties, bear with me just a second. There we go. Knuckle to mid-shin is here. Then we got knuckle to shoulder. And then 12 inches above the shoulder. From the shoulders up to 12 inches above the shoulder is the fourth category for vertical zone that they use. All right, let's go ahead and take a look at the table, and then we're going to do an example problem here in just a second. Okay, we're using the table to determine the weight limits for workers. First, we need to determine the duration and the frequency. How many hours are they working, and how many lifts per hour are they executing during their workday or during that work period. Now you may have to estimate or take an average for a particular task to come up with your lifts per hour number. Once you find your frequency, then you're going to select the appropriate table based upon that frequency. Again, table 1 is for low frequency, up to 2 hours per day with up to 60 lifts per hour. or greater than 2 hours per day with up to 12 lifts per hour. In Table 2 is your moderate or somewhat frequent range. And I won't read all this to you again, but it's we've already covered it, but that's moderate frequency. Then high frequency is Table 3. After we determine which table to use based upon frequency, we're going to determine the horizontal zone. Again, that's how close the load is to the worker's body. Then we're going to determine the vertical zone, which is the starting point of the lift, of the load. Is it on the floor? Is it on a shelf at 35 inches? That's going to determine the vertical zone, the starting point of the load that we're lifting. Then after we find that information, we're going to find the recommended weight from the table. Okay, let's do an example. Okay, we have a workplace where once a day a truck arrives carrying a load of bottled water. The bottled water is in 24 packs, and all of the 24 packs of bottled water must be unloaded. A worker picks up each of the 24 packs and carries it 8 feet and places on a shelf in the warehouse. And it'd be better if they used a forklift or some type of lifting device, but we don't have that option. Let's just assume we don't have that option. The only way to do it is manually. Pick it up and carry it 8 feet. Each time the truck arrives, the worker unloads 180 of these 24 packs, and it takes him or her 1 hour and 30 minutes to unload and move these 180 24 packs. That works out to a hourly rate of 120 per hour, and that's 120 per hour. That rate, along with the total duration of the task, will determine what frequency level we're at. The packs are stacked in 4 tiers. When they arrive on the truck, they're stacked in 4 tiers. Picking up the lower tier requires a lift from floor or foot level. So our vertical distance that we're going to use when we use the table is mid-chin to floor. That vertical distance, that's the starting point of the lift. Now again, there are 3 tiers above that, but we always want to start with the lowest tier when using a table like that. If we start with the lowest tier, we're not going to be overloading the worker. Now if we started with the top tier, that might result in us having a weight limit that's greater than it should have been. So start with the lowest tier in a situation like this. And in this case, it's mid-shin to floor is going to be our vertical distance starting point. Our horizontal distance is close. We're able to keep the load less than 12 inches from the body. So again, everything I've underlined here, that's going to help us determine the weight limit. First thing we need to do is find the correct table based upon our frequency. Based upon a duration of 1.5 hours and 120 lifts per hour, let's look at these subtables. Doesn't fit table 1, and it's not as frequent as table 3. So table 2 is going to be our table that we use to determine the maximum lifting weight for this task. Again, 1.5 hours, 120 lifts per hour. This is, let's just review this, up to 2 hours per day. We're less than 2 hours, so that's correct. And 60 to 360 lifts per hour. 120 lifts per hour is within that range. So we've selected the correct table to use. Now we need to use the horizontal distance and the vertical distance to find the weight limit for the task. The vertical zone is mid-shin to floor, and that's based upon the starting point of the load, and it's mid-shin to floor. And this lower row in the table represents mid-shin to floor vertical starting points for the lift. So that what I've highlighted there, that's where we need to be. And we can already assume it's going to be either 20 pounds or there's no known safe limit. Those are the only other options. But again, we need to look at horizontal zone also. It's not just vertical zone, it's horizontal zone. Our horizontal zone is close, less than 12 inches. We find the correct column from the table, and it's right there. Now, where the column and the row intersect, that's our weight limit, 20 pounds. Our weight limit for this task should be 20 pounds, no more than 20 pounds if we're using the threshold limit value. And that's what TLV stands for. If you don't remember from industrial hygiene or other classes, that's the threshold limit value that should not be exceeded for this particular task as far as the load weight. If our 24 packs are greater than 20 pounds, we're exceeding the TLV. And when we exceed the TLV, we increase the likelihood that an injury will occur. Okay, so let's think about this. Let's say we do have the 24 packs are heavier than 20 pounds. Now our limit's 20 pounds. What can we do to make it safer for the worker? The 24 packs weigh 25 pounds, the limit is 20 pounds. How can we change the task so we are within the lifting limits? Now I'll just go ahead and give you my ideas. I'm sure as you're watching this, you're thinking, well, we could do this or that. I'm sure you guys come up with great ideas. If this were a conventional class, we would discuss back and forth possibly some different methods. Let me just go ahead and give you some possibilities. We could reduce the frequency and the duration by using 2 workers instead of 1. We could add another worker to the operation. Instead of having one person unload the whole truck, we assign another person to help with the unloading. Again, that's going to change the frequencies per hour, the frequency of lifts per hour, the rate of lifts per hour. And it could also possibly reduce the duration, but we're mostly interested in reducing that frequency rate. Still, for me, it would still be okay if it took an hour and a half, but I want to get that frequency rate down from 120 lifts per hour. We could also possibly change the starting height of the lift from the floor foot level to the mid-shin. We could change it from mid-shin to knuckle. Maybe we could request that the vendor deliver the loads on a rack where the water bottles are at the mid-shin to knuckle range. And that's probably, I think the best thing to do though is just add another person. Add another person to the operation. And here's what it could look like if we added another person to the operation. The frequency changes from 120 lifts per hour to 60 lifts per hour, assuming that each person did an equal amount of the work. So when we're in that range of 60 lifts per hour, we are in table 1. We're in the infrequent or the low frequency subtable. And we'd use the same approach. At 60 lifts per hour, with the decreased frequency, the limit is 30 pounds. Again, still mid-shin height to floor. That didn't change. It's still close. That didn't change. But because we reduced the frequency, now the lifting limit is 30 pounds. And again, based upon the ACGIH TLV, that should be safe for a healthy worker in optimal conditions. Now, if the floor was wet, if the wind was blowing excessively, and they were exposed to the wind, some other environmental conditions weren't optimal, then you might want to lower that below the 30-pound limit. And that kind of gets in, that last point I made kind of goes along with this slide, adjusting the lifting TLV. Again, it is unadjusted in the table, and it assumes optimal lifting conditions. If we have high asymmetry, meaning the load is unbalanced some way or another, we're not able to keep it in our midline. It's off to one side or another during the task. That would be suboptimal. if the worker is seated while making the lift, which wouldn't apply to the example that I've used, but let's say we have a worker seated at an assembly line. They're taking objects off the assembly line and placing them in a box. Again, because they are seated, we would have to use a different, we would have to adjust the lifting limits. Or we could also recommend that the worker performs the task while standing. If they are working on an uneven work surface with poor footing, that would require an adjustment as well. If the carry distance was, in our example, the carry distance was only 8 feet. Let's say they had to carry each 24 pack 50 feet. That would justify adjusting the lifting limit downward. Now that's one of the weaknesses of this table and this method, is that it doesn't give you any specific rules for making adjustments. That's left to your discretion, to your critical thinking. But it's left to your best judgment what the adjustment needs to be. And if you did end up in suboptimal conditions for the task, one of the first things you'd want to do is try to improve those conditions. If you couldn't improve those conditions, then you would consider limiting the weight of the load, going below what the table says the weight of the load should be. Some other weaknesses or criticisms possibly of this method, of these tables, may be overly conservative, and it does not account for the vertical distance the load is moved. You have that vertical zone, but that's just the starting point. It doesn't take into consideration that you're picking it up from the floor and moving it overhead. That really should be taken into consideration. But back to the overly conservative concern, because it is so overly conservative, a lot of employers would look at this and say, there's no way. Our workers have to be able to lift more than 20 pounds. There's no way we can accommodate our workers if that's our lifting limit. But again, even though that may be the initial response from the company, it might be worth pursuing, because there are ways of reducing or making it more worker friendly. And one example is what we just went over. If instead of having one worker perform the task, give him a helper or a couple of helpers, depending on what the job is. All right, that's all I've got. Let me know if you have any questions. Now, there is a practice problem on Blackboard. What I would like for you to do is go in and identify the recommended weight limit for the task that I've outlined over here. Then also, after you provide me with that recommended weight limit, you then come up with the recommended weight limit for the task if the assembly line was set at 12 inches. This particular slide is available. You go to Blackboard, under problems, assignments problems, and then you'll be able to find this assignment with this slide and additional instructions. Again, as always, if you have any questions, let me know. Good luck, and I will see you in the next video lecture.